This is going to be a short video on this other little experiment project I've been working on. It's a pin walker with a sort of steerable side to it. It'll go in forward. I'm controlling it with a universal remote. Stop. This is reverse. In reverse, one side disengages and the other side runs in reverse to give it a little bit of a steerable action. Definitely needs some fine tuning. It needs a faster motor, I believe. And then stop, and then when we go back to the forward, it engages both sides again. This is just a universal remote setup for a Sony TV. It's right now it's controlled by this tiny microcontroller with a IR receiver right here, and this little board back here is one of those cheap L9110S, I believe it's called. One side of it, it's a dual H bridge. I'm only using one side. Here is a mechanical part that I'll try to explain. The shaft, this is just like the other ones other toys I've been building. Little two bevel gears. This shaft is driven. This crank is always driven by the shaft. This crank here is connected to this disc, which has a ratchet mechanism on it. It is not connected solidly to the shaft, so it can rotate freely. This little disc here is connected solidly to the shaft. There are two magnets in this. You can see the screwdriver being attracted to them. There are two magnets mounted in here and two magnets mounted in this free spinning disc. They sync up together, and that's what keeps the motion in sync, because the pins have to be driven 180 degrees out of phase from each other for it to walk. What makes it one side stop is this ratchet mechanism that there's a ratchet and pawl mechanism. I'll just go ahead and run it. Hopefully that stays in focus. I have a terrible time keeping things in focus. When it runs in reverse, this pawl catches this disc and stops it from turning this side. Stop it, go back forward again. When it goes back forward again, the pawl is released and the two magnets sync up together and drive both sides. So try to get that. I don't think it was out of focus before. Reverse. You can see that it catches. Stop. Forward. The magnets have to be strong enough to overcome the spring tension on this pawl. Once again, reverse. And forward. Let it walk a little bit again. That's forward. This is reverse. It seems to stay in sync. I tried another method that didn't work so well. It used a little spiral spring type device. Walks forward really well. I take a faster motor and maybe changing some of its geometry right here might help improve its speed a little bit. Originally, I was going to control it as a wired device or a wired toy, but the wire turned out to be so stiff, even though it's not really that stiff. And this is so light without all the battery and electronics on it that it was hard for the wire had more influence on the direction than the pins did. So that's why I cobbled this all together to see what the problem was. Another method of controlling it might be to use like a double pole, double throw relay with a timer off circuit so that a bump switch, it could bump into something and then go and turn a little bit and then take off forward again. I might work on that a little bit. I think a 5-volt relay would probably pull in with these 4-volt batteries. Just have to do some experimenting and see. This is one of what the disc looks like. There are magnets on each side. This one here was the first attempt at it. It only had one magnet here and one here, and it was not strong enough to overcome this and also to drive the robot. So now it has 2 deep magnets in there. They're 6mm by 1mm magnets. And that seems to work pretty well. Always might be room for adjusting. Back forward again. And reverse. I just thought I would make a video because I thought it was kind of interesting. It's a lot of fun designing these little mechanisms. I used Fusion 360, and it's really a very powerful program. Well, thanks.